All right, everybody, this is the force calculation practice problems. I want to let all the seniors know in my first period class that you are being videotaped right now. Anything that you say or do will be held against you for the rest of your life on JCPS Online. What we're going through right now is Newton's second law. I know I'm doing the law sort of out of order, but what does Newton's second law say? Congratulations, that's exactly right. That force is directly proportional to acceleration. And mass is inversely proportional to acceleration. Well, first of all, let's talk about what that means. If you're directly proportional, that means that your computer stops working. No, it doesn't. Okay, that means that if one thing goes up, what happens to the other? No. Yeah, it goes up. So if force goes up, that means acceleration is also going to go up. So if I put more force on you, you're going to accelerate more. Say again? I have to unfreeze the screen so they can see it too. All right. And then if mass goes up, if you weigh more, what happens to your acceleration? And then it goes down. Very good. So I'm going to have a brand new formula here that's going to sort of put that definition into math here. So I'm going to say that F is equal to m times a. So if you cover up the a here, if you notice, acceleration equals F divided by m. And that does make sense because we said if, I don't know why I started turning purple, that was weird. It's really strange. Let me just stop this for a second. Kai wants to do a shout out to his mother. Happy birthday, Mom. We love you. And so, once again, we're going to do F divided by m. So you can see that if F gets bigger, so does A. But if M gets bigger, A goes down. So if you would have twice the force on something, let's say the force was 1, but you double it. If you notice, and mass is 1, you notice acceleration goes up by 2. If you double the mass, though, I'm going to scratch this out. If you double the mass, have that 2 times 1. Now, if you notice, acceleration went to 1/2. So that just, once again, proves that if force goes up, acceleration goes up. If mass goes up, acceleration goes down. So the first thing I want to do is a problem from last chapter. And it says, what is the acceleration? So Spencer, what letter am I looking to find? Congratulations, it's A. Of a car that speeds up from 0 meters per second. So what letter in the formula is that, Aaliyah? Exactly right. That's the original velocity there. And it goes from 0 to 30 meters per second. So dominate the 30 meters per second is your final velocity. Great. I don't know if you can't hear them, but they're giving all the right answers. In 5 seconds. So Carly, that's what letter? Time. Great. And so you can't use the A equals F over M because all I know is A, B, and T. So Kai, do you remember what formula has all those in it if you're looking for acceleration? That's wonderful. Yes, acceleration equals change in velocity over change in time. So I'm going to take my final velocity, which was 30, subtract from it the original velocity, which is 0, and divide that by my change in time, which was 5 seconds. You get 30 divided by 5, which gives you 6. This is meters per second. And the units for acceleration are exactly right, meters per second squared. You guys are so sharp at 7 or 8 o'clock in the morning. Let's go to number 2. If you would read that for me, Kai. Stop right there. Exactly right. What force? So what letter am I looking for? F. Very good. Keep reading, champ.
It's needed to speed up a
4.5 kilogram bowling ball. So 4.5 kilograms, Spencer, is going to be what letter? M. Good. And then finally, the bowling ball is at what speed or what acceleration?
5
So that's going to be A. Now I have to come over here and figure out what formula I'm going to use if A equals F over M in this triangle. What are you going to cover up, Carly? The F. Very good. So if you cover up the F, if you notice, it's M times A. So F equals MA. So I'm now going to put my 4.5 kilograms in for M. I'm going to put the 5 meters per second in for, or squared for acceleration. And 4.5 times 5 gives you 22, I think. And that comes out to kilogram meters per second squared. Now, that's just too big of a unit. 22.5? Thank you. 22.5, guys. And so That's too big of a unit. So what Newton did, since he was the guy that studied all this, is he wrote to the System International and said, I want a unit named after me. And so what they did, all the units for force were named newtons. So this 22.5, instead of a kilogram meter per second squared, is simply called a newton, as in fig. You might remember the old Fig Newton commercial where the guy comes out with a cookie and he bites the Fig Newton, and after tasting it, he says, "It is not a cookie, it is a fruit cake." If you don't remember that, it was funny. Okay, let's go to the next part. Aaliyah, read number 3 for me. Stop right there. What letter are you looking for? A. So we're going to look for A here. Let me put this in green. Keep going. It's produced by a Newton. Very good. So Dominic, 50 Newton's going to be what letter? F. And keep going, Aaliyah. So the mass is 15 kilograms. Tell me what formula you're going to use, Spencer. If you're looking for A. Very good. I went purple again. That's really cool. And so we're going to take the 50 newtons. I need some help on a calculator if anybody's got it. Divided by 15 kilograms. 3.3333 repeating, right? And acceleration is measured in meters per second squared. Great. All right. 2 more and we're done. Probably read the next one for me. Stop right there. We're looking for M. Keep going.
Of a baseball bat and he needs to produce 2,500 newtons.
Stop right there. Kai, what's 2,500 newtons? What letter in the formula? F. Very good. Keep going.
A force on the ball and accelerated at 17 meters per second.
Looking squared. Yeah, it's a square there, not a 2. So therefore, that's your acceleration. Let's figure out what formula we're going to use for mass. And Dominic, what formula are you going to use there? M equals what? F over A? Uh-oh. This is weird. I think the ghost of male high school keeps turning it purple. And so I'm putting it in the wrong place. No wonder it's turning it purple. So M equals F over A. Dang on, that's weird. So I'm going to put in the 2,500 newtons. Need a little help on the calculator if you got it. Divided by 17 meters per second squared. I'm sorry, Spencer, what did you say? 147.06, and mass is measured in kilograms. Very good. Let me erase this over here. And where's my eraser? There it is. Wow, even the computer squeaks. And then let's do a blue. Finally, let's read the last one here. Aaliyah.
What is the weight?
Stop right there. So I'm now looking for W. But if I stood on you, wouldn't my weight be the same thing as a force? So therefore, weight and force are going to be the same thing. Keep going. So that's now the person's mass is 55 kilograms. Keep going.
The acceleration due to gravity is 9.8.
It's 9.8. So this is your acceleration. Now, I can use this formula of F equals M times A. Come on. This is purple. All right. But what the heck? Hold on. Let me stop it. Spencer just asked a great question. He said, does it have to be a capital F? And the answer is yes, because little f is going to stand for friction. And we're going to get into that this chapter as well. Okay? So on this right here, if I don't want to use if I'm using weight, we can also say that W equals M times G. And G from last chapter was always what number on Earth? Yeah, 9.8. So we're going to do W equals mg, or women marry guys. And so if you want to know your weight, if you're 55 kilograms, simply multiply that 55 times 9.8 meters per second squared, and you're going to end up getting somewhere around 500-ish, 539. And weight and force are both measured in what? Newtons. Very good. So if you're, most of your average weight should be around 539 newtons. All right. Have a great night. Hope you enjoyed the show. What your homework is to do the back of that worksheet, which are the same types of problems, just different numbers. Hope you enjoy the rigor of this course. Love you. See you later. Bye.